The Northwind Employees table contains a column named Reports To, which holds an employee ID value from another row in the table, or a null value if the employee doesn't report to anyone. Suppose you need to run a query showing the direct and indirect reports for a particular employee. Without support for CTEs or common table expressions, you would need to resort to procedural code to solve that kind of problem. All right, so here's an example function. It uses multiple queries and procedural logic to generate the list of direct and indirect reports for a root employee. This is a table-valued function, so it defines the table that it's going to return. So as you can see, it's going to return the employee ID, who they report to, and their level in the hierarchy. And then the code starts out by declaring a variable to record the level of each employee. And the first thing it does is it inserts into the table generated by the function the root employee, the employee that is being requested. And then the function runs a loop that retrieves additional employees who report to the root employee or to one of that employee's reports at each successively deeper level until it finds no more reports. So this is the kind of procedural code that you need to write without common table expressions. So I'll go ahead and create that function. And then execute it. And there you have. So whoever employee ID 2 is doesn't report to anybody, so that's apparently the big boss. And then employee 1 reports to 2, and that's one level down in the hierarchy. 3 reports to 2, 4, 5, and 8 all report to 2. And then 6 reports to 5, who in turn reports to 2. So that's how that employee hierarchy works. But this implementation is decidedly not set-like. You have to use this loop here in order to process the data procedurally, in order to generate the output results. Now, a common table expression lets you accomplish the same result in a single set-based query, which runs much more efficiently and is easier to write and maintain. So here's a version of that function that uses a common table expression. So this common table expression follows the exact pattern of the reports function that I just showed you, but uses much more efficient syntax. So in this case, once again, accept a link to the employee that we want to use as the root employee, and this is going to return a table. We don't have to define the structure of the table because it's going to be defined as the results returned from the function itself. And then the function defines 2 queries within this with clause. This identifies a common table expression. So the common table expression is called reports CTE, and that's what's going to be referenced from an outside select statement that actually returns the records from the function. All right, then within the definition of the common table expression, you have an anchor member right here and a recursive member. The anchor member is essentially the starting point. This is the equivalent of that statement in the previous function that retrieved the root employee. So it's just a simple select statement. It's employee ID, who they report to, and 0 is the level, from employees where the employee ID is equal to the root. And then those results are unioned all with the recursive member results. The recursive member references itself, and it automatically uses the results from the last time it ran until it returns no more results. And so again, the overall processing is the same, but because I'm able to break this out into an anchor member and then a recursive member here, you don't need the procedural logic in order to process all of the employees in the hierarchy relative to that root employee. All right, so I'll go ahead and create this version of the function and then execute it, once again using employee ID 2. And you can see that we get the same results. So once you get used to writing common table expressions, you'll find that they're much easier to create and easier to maintain. Because in this case, all you're really doing is breaking everything out into 2 different queries and then creating this as a recursive query. And essentially the recursion comes right here when it's joined onto itself. This is the name of that common table expression within the function. But there's benefits that go beyond just easier to write code. So here I have those two select star statements, same one right there and the one for the previous function. So what I can do is highlight both of these statements and come up here and display the estimated execution plan. This actually generates three different plans. There's one for the select star from function reports, and then one for that function reports itself. So out of those two statements, the combined total of running that function reports is 4 plus 87. So 91% of the total execution cost is taken up in that first query, the non-common table expression. Then if I scroll down here, this is the plan for the common table expression version. As you can see, it's a mere 9% of the overall processing. So it's a much more efficient query compared to the non-common table expression. So not only is the common table expression easier to write, it actually performs dramatically better than the original version of the function.